Thomas Edison invented the first marketable electric bulb. Throughout his invention, his industry burned down. He reportedly lost $23 million and his dog destroyed his research papers. Oops, that was Newton's dog. Nevertheless, his carbon filament and oxygenless bulb combo was a huge hit with his bulb lasting up to 600 hours. At present, we have a blinding array of electric lamps such as halogen light bulbs, fluorescents, sodium vapor lamps, LEDs, and so on. Fluorescent bulbs. Fluorescent bulbs are more complex than incandescent bulbs. In the fluorescent tube, the electric current passes between cathodes, exciting the mercury and other gases filled inside the tube, and radiate energy. The phosphorus coating on outside converts radiant energy into visible light. Its drawback, the fluorescent tube gets incredibly hot, making it dangerous to human contact. So now we know the real truth behind Star Wars lightsabers after the joke. Vapor lamps. Sodium, mercury, other vapor lamps, which are commonly used for lighting streets, gymnasiums, and other large areas, are also tubes that run electrical current through a gas. The gas itself emits mainly visible light, so these bulbs don't need fluorescent coating. Light emitting diode, LEDs. LEDs are also like fluorescent light bulbs, except replace the gas with a tiny crystal of semiconducting material and throw away the bulb. So not like fluorescent bulbs. The semiconductor device in which the electricity is supplied to the negatively charged diode, resulting in the flow of electrons and release of photons. The photons combine to emit light from the diode.
Now let's check a LED bulb. This is one of the most commonly used latest generation LED light bulb. Obviously, they fit into any standard socket. They are about the same size as the old incandescent lamp. The plastic part is a real bonus because unlike the thin glass of old incandescent lamp or tubes of filament bulbs, they don't break and this is pretty tough. Now let's check what's inside this bulb. Here is what I found. The LEDs are these yellow square-like structures and each of them is a white light emitter. The LEDs are arranged on a metal printed circuit board. The PCB board is placed on a metal bottom and as expected there is no heat sink. This is the power supply. The circuit is very simple. Here we have two capacitors, one big and a small one, both with different capacitors marked on it and rated for 105 degrees Celsius. That's barely good enough to survive the heat created inside the working bulb. The other components of the circuit are two resistors, a bridge rectifier and an inductor. So this is the simple circuit that regulates the power supply to the PCB board. LED isn't really a new device. Somewhere or another, it has been used all around the globe for decades, in such as TV remotes, traffic signal lights and all. But right now, we are experiencing an LED boom in illumination technology. There are several factors which led to this, such as high efficiency, low heat production, availability of different colors, easy disposal and low cost. This is just story of a LED bulb. Light emitting diode has several other applications too. Let it be a story for another day.